I think we should start by now, no? Acha, Harsha, join. Let's see that. Harshada, am I audible properly? And is my screen visible?
Yes, sir.
So we have done free radical calculation of alkenes, and we are in the from hydrocarbons section. So the second method of preparation from hydrocarbon will be by aromatic substitution. Electrophilic aromatic substitution. Now, what is electrophilic aromatic substitution? This is basically chlorination or bromination of benzene. When we have benzene, we use Cl2 in the presence of anhydrous AlCl3. And fluorine attaches to one of the carbons on the benzene ring. All the carbon atoms are equal, so you can attach this chlorine in any one of the carbon atoms. One important point here is Cl positive or Br positive, whatever you are going to take, acts as an electrophile in electrophilic aromatic substitution. Okay. So electrophile, that means it is acting as an attacking reagent. Electrophile, nucleophile, these are attacking reagents. Similarly, you can use Br2 in the presence of FeBr3, or you can just use Fe. Here also you are going to get bromine in any one of the carbon atoms. Now, in the case of substituted benzenes, what does it mean substituted benzene? For example, if you have CS3 on the benzene ring, and if you add here Cl2 in the presence of, again, very same thing, anhydrous AlCl3, you will get two products. CS3 will be as it is. You will get ortho substituted Cl plus you will get para substituted Cl. Okay. That is O-chlorobenzene and that is P-chlorotoluene. Got this?
Yes, sir. So can you?
Darshita, I could not hear the last thing.
Can you scroll up? I didn't write the whole thing, sir.
Just a second. One more thing. For example, if you have minus M groups such as NO2, then in this case, when you are doing chlorination, bromination, whatever, you are going to get chlorine in the meta position. Okay, check. Rishita, let me know once you're done typing.
Done, sir.
You can write more. Electron donating groups such as alkyl group or hydroxy group OH or NH2 or alkoxy when attached to by the way इसमें ना एक और ये भी आ जाएगा फॉर एग्जांपल इवन हैलोजेंस आर आल्सो ऑर्थोपैराडायरेक्ट ठीक है when attached to benzene ring they give ortho and para products ठीक है बट इफ यू हैव इसमें बस एक चीज ना हम हैलोजन को आई एम representing it as red because halogen even though it gives orthopara product but it reduces the reactivity है ना because reactivity is determined by the site orientation of where it is attached it is determined by the plus m and minus m effect. So it shows plus m effect, but overall ये electron withdrawing group होता है, ठीक है? But it will give you ortho and para product. Next thing is electron withdrawing group, such as CHO, double bond O and R, C double
Sir,
bond
your
O,
voice is
OH.
breaking a lot.
Yes. Rishita, how is it now?
Now it's fine, sir.
That's fine. CONH2, or if you have C double bond O attached with OR, okay. So when all of these groups are attached, when attached to benzene ring, they give meta products. Okay, they give meta products. After this, you will write the third method of preparation. From alkenes. Done writing, Prishita?
Yes, sir.
ठीक है. So from alkenes, here also we have a few methods. So इसमें सबसे पहला method है. We have this method that is known as halogenation of alkenes. So in halogenation of alkenes, what happens? You have carbon, double bond carbon. In alkenes, this is the reactive site. You have to just look at the alkene part when you are having. You have to just look at the double bond part of the molecule when you are reacting with alkene. So alkene, it will react with any halogen, H2. And it is going to give you guys one halogen. one halogen here, and the other halogen will be on the adjacent carbon. Now, since both the halogen atoms are in vicinity to each other, vicinity मतलब अगल बगल में सामने सामने है, that's why these are known as vicinal halide. Vicinal halide. ठीक है. Now you can write a statement. When alkenes are treated with halogen, they form vicinal dihalide. Vicinal dihalide. एक यहाँ पे भी डाई लिख दीजिएगा. ठीक है. Vicinal dihalide. Now please see. Right note. Bromination is used as a test for unsaturation. Bromination is used as a test for unsaturation. क्या मतलब? For example, if you have CH2, double bond CH2 plus Br2, then you will get CH2, CH2, both the carbon atoms will be having Br. Now, this Br2 that we are having, it is brownish in color. Okay, it is brownish red in color. Brownish red. But as soon as it reacts with alkene, this will become obviously what? Colorless. So if they ask for a test like how will you differentiate between alkane and how will you differentiate between, let us suppose, ethane and ethene? So you will say that ethene will react with bromine, है ना? And or rather you will write ethene when reacts with bromine, it decolorizes the brownish red color of bromine, but ethane does not. ठीक है, तो इस तरह से आंसर लिखिएगा. बेसिकली आपके आंसर में क्या रहना चाहिए? Whatever, like for example, you have something versus alkene. How will you test? You will write alkenes decolorizes bromine water. ठीक है, that's it. You have to write alkenes ethene decolorizes bromine water, but ethane does not. Propene decolorizes bromine water, but propane does not. अगर आपके पास है आंसर, ठीक है. After this, you will write questions. Write the products. Alkene decolorizes bromine water तक लिख लिया आपने?
हाँ सर.
आई एम गिविंग यू क्वेश्चंस, ठीक है. अगर आपको चाहिए ना कि हम कोई एक सा कर दे, देन जस्ट लेट मी नो, आई विल डू वन फॉर यू, देन यू कैन डू द रेस्ट ऑफ देम. वन से फोर तक में बताइए कौन सा कर दे. If you want, otherwise it is very easy. You have to remove the double bond, but see what is happening in the previous reactions now. You have to remove
Yes,
now,
sir.
instead of double bond एक एक Br आपको लगा दें, एक Cl लगा देना है, जहां जिस कार्बन में डबल बॉन्ड था, कर लेंगे।
Yes, sir. I'll try.
ठीक है। Okay.
So for the fifth one, how do we do it?
Fifth one, note quality है, notes quality है। Isn't this reaction already there in your notebook? See?
Yeah, it's there. Yes.
तो बस इसका ध्यान रखना है ना। Like for example, I mean, fourth and fifth, there is very slight difference, but the products are completely different. Okay.
So the fifth one, the double bond will still be there, right?
Yeah, correct. Exactly.
Okay. I sent the photo to you, sir.
Okay, fine. I've not received it yet. Yeah, just got it. Yeah, very good. Everything is correct. Br and Br. Yeah, very good. Check. एक और सवाल कीजिए. Just give me a second. देखिए एक सवाल है. A hydrocarbon C5H10 does not react with chlorine and dark, but gives a monochloro compound C5H9Cl in bright sunlight. Identify the hydrocarbon. Okay. So what they are trying to play with is, if you look at this formula C5H10, what do you think? It is alkane, alkene, or alkyne?
Alkene.
Alkene. So obviously, okay. So C5H10, but what they are saying, it does not react with chlorine and dark. It does not react with chlorine in dark. That means in the absence of light. So when we have alkene, alkene we are using dark. We are not using any light in alkene, but it is saying that hydrocarbon C5H10, it seems like alkene. It does not react with chlorine and dark. That means it is not an alkene. So what is it? So C5H10, what is it? It will be a
Cycloalkene.
pentane. A cyclopentane. है ना? 5 carbons, so cyclopentane. ठीक है? Now it
Pentane.
is saying it gives us cyclopentane.
So
It
is there
gives a
something
single
called like
monochloro compound.
cyc?
साइक्लोपेंटेन तो सही तो कहा आपने.
No, no. Is there something like cyclopentene or like anything with alkene instead of just alkane for cyclo?
But yeah, you can have cyclopentene, for example, here like this, but it will not be C5H10.
Okay, sir.
Because if you make a double bond here, now here we have only one hydrogen and only one hydrogen. Here we have two hydrogens, here we have two hydrogens, here we have two hydrogens. It will be 6, 7, 8 hydrogens only. Make sense?
Yes, sir.
No. So if I have cyclopentane and I react this with chlorine in the presence of bright sunlight, so sunlight आप लिख दीजिएगा. What will happen? Okay, how many different types of carbon atoms do we have here?
5.
Tell me.
No.
But
1.
only one type of carbon, and that is why you will get only one product. Make sense?
Yes, sir.
Then write C5H10 is not alkene as it does not react with Cl2 in dark. Let me know once you're done. Then we will move on.
Done, sir.
Okay. So while using alkene, first is halogenation of alkenes. Second one is hydrohalogenation of alkenes. This is going to be hydrohalogenation of alkenes. Now, in hydrohalogenation of alkenes, what happens? We have again carbon double bond carbon with some groups attached, plus you have a hydrogen halide. What is going to happen here? It is going to, one of the carbon atom will get hydrogen, the other carbon atom will get halogen. ठीक है, एक कार्बन पे हाइड्रोजन, दूसरे कार्बन पे हाइड्रोजन. For example, if you have CH2, double bond CH2 plus HBr, then let us suppose this first carbon atom is getting hydrogen. It will become from CH2 to CH3. Double bond will be converted to single bond, and you will have CH2. The CH2 will get a bromine atom like this. Similarly, if you have something like this, plus let us suppose you have HCl, then one of the carbon atom it will get hydrogen, the other will get chlorine. The one which is getting hydrogen, we don't have to show the hydrogen. We just need to convert the double bond to single bond, and this will become Cl here. So it doesn't matter whether you attach the Cl carbon atom in this carbon atom or this carbon. Both the carbon atoms is going to give you the same product, that is 2-chloropropane. Similar is the case for, sorry, 2-chlorobutane. Similar is the case for the ethene case. So here you are getting, whether you attach here or you attach on this pink carbon atom, in both the cases you will be getting bromoethane. Similarly, if you have something like this, let us suppose plus HBr. Here also you can attach in any one of the carbon atoms and you will get bromocyclopentane. It doesn't matter which carbon you are attaching, in which of the double bonded carbon atom you are attaching. You have to attach on one of the double bonded carbon atoms after removing the double bond, but it doesn't matter. You have this carbon P, S carbon, it is going to give you the same product. This is the case for the symmetrical, when the alkene is symmetrical. Okay, so we'll write also one more thing. When alkene when alkene is symmetrical, attach halogen to any one of the doubly bonded carbon atom and attach hydrogen on the other carbon. Okay, but I hope you understand that you have to remove the double bond. ठीक है, you have to identify which carbon had the double bond. फिर वहां से आपको वहां पे आपको लगाना पड़ेगा. ठीक है, चलिए, please copy this down. और एक सवाल आप कर लीजिए जरा, हमको थोड़ा इत्मीनान हो जाएगा.
So you put the PR on any one of the double bonded carbons, right?
Hmm. Yeah, correct. Anyone. If it is symmetrical. For unsymmetrical case, we are going to see.
This is not symmetrical?
This is symmetrical.
Okay, then yes, I am done.
Hmm. Yeah, very good. That's fine. That's correct. Now, in the case of unsymmetrical, I will tell you how to form the product first. And after that, we will look at the mechanism and everything. Fine. So please see. You will identify the carbon atoms which are in the double bond. We have the blue one, and let us suppose we have this red one. Can you tell me how many carbon atoms in the blue one? Sorry, how many hydrogens in the blue one?
One,
One. And how many in the red one?
uh, two.
Oh, there you go. So that's the only thing that we have to do. Okay. Once you have identified, then what will happen? You will get both the products. You will get one time the chlorine will be in the blue carbon and chlorine will be in the red carbon atom. But the carbon which is having lesser number of hydrogen will be the major product. ठीक है, इस तरह का आपको कुछ सेंटेंस याद आ रहा होगा, 11th में भी हम लोगों ने पढ़ा था, द नेम ऑफ मार्कोनिकॉफ्स रूल. ठीक है, याद आया कुछ नहीं याद है?
Yes, sir.
नेगेटिव पार्ट ऑफ दी, है ना? सो यू हैव टू जस्ट
Yeah,
आइडेंटिफाई द कार्बन व्हिच
hydrogen
इज हैविंग लेस
always
नंबर.
bonds with the carbon which has the most hydrogen.
या करेक्ट, एग्जैक्टली. तो फिर नेगेटिव पार्ट वाला जो है ना, HCl हो गया, Br हो गया, ये कहाँ पे अटैच करेगा? इट मींस गोइंग टू अटैच ऑन द कार्बन एटम व्हिच इज हैविंग लेसर नंबर ऑफ हाइड्रोजन. ठीक है,
Yes, sir.
चलिए. बाकी कर लेंगे आप खुद से.
Yes, sir.
ठीक है, बट प्लीज डू दिस वन. हाँ, you will circle the carbon atom which is in double bond, then you will write the number of hydrogen for each of the carbon atoms, and then only you will write the product. Okay, ठीक है.
Yes, sir.
डायरेक्ट मत कीजिएगा, डायरेक्ट कीजिएगा तो फिर गलती होने के चांसेस. For the first, okay. Only one you have done. Yeah, that's fine. That's correct. That's right. You have done the rest also. Yeah, very good. Correct. So the mechanism that happens here is known as the Markovnikov addition. Okay. So write the product CH3, and here you will have Br. Here you will have chlorine. Here you will have iodine. Here you will have Br. ठीक है चलिए these are the major problems. Now is right Markovnikov's addition. Markovnikov's addition. What happens in Markovnikov's addition? Negative part of the reagent attaches to that carbon, which has lesser number of nitrogen. Okay, now how the reaction happens, the mechanism. So please see, we are going to look at this reaction. We have propene plus HBr is going to give you two products, that is 2-bromopropane and 1-bromopropane, where the 2-bromopropane is going to be major and this will be minor. Now, the first step in the mechanism is we have alkene and HBr. So what will happen is alkene and you have HBr. So hydrogen will be having a delta positive charge because Br is electronegative. It will be pulling electrons from the hydrogen atom. Now what will happen? The alkene, which is electron rich, it is going to attack on the hydrogen atom. Now once it attacks on the hydrogen atom will attach on one of the carbon atoms, which is having double bond. It will either attach on the red carbon atom or it will attach on the green carbon atom. I mean, it will attach on, so for some of them it will attach on red, for some of them it will attach on the green. Whatever is more stable, that will be produced in larger amount. So what will happen? Let us look at the, if it attaches on the green one, if it attaches on the green one, then what will happen? You will have 3 carbon atoms as it is. The hydrogen will be attached here. There will be a positive charge on this carbon atom. Similarly, if it attaches on, if the hydrogen attaches on the red carbon atom, you will have hydrogen here, and the positive charge will be on the last carbon, terminal carbon atom. Plus, you will get a Br negative in both the cases. Br negative will be common in both the cases because Br negative is taking the electrons from hydrogen and going. Now, if I look at the degree of carbon atom, then this is 2 degree carbocation and this is 1 degree carbocation. So obviously 2 degree carbocation is more stable. That is why it is going to undergo the rest of the reaction. Or rather, I should say more stable. More stable. And since this is more stable, this carbocation will be formed in a very large amount and this will proceed to the further reactions. So दूसरा reaction क्या होगा हमारे पास? दूसरा step में होगा positive charge plus Br negative. Br negative will attack onto this carbon atom and we will get Br like this. And if I take this one, the positive charge here plus Br negative, the attack will be a similar pathway. And we will get Br in this carbon atom like this. Okay, this is the mechanism for Markovnikov's addition. Please copy this.
Done, sir.
Okay. Now, similarly, ना अभी इसी में हम लोग एंटी मार्कोनिकॉस रूल लिख लेते हैं, and after the anti Markovnikov rule, we will do some questions. Right, next, anti Markovnikov addition or anti. Anti Markovnikov's addition. ठीक है ना। सबसे पहली चीज, इसके कुछ और नाम दिए हैं, AKA peroxide effect और खराश इफेक्ट। Kharash was the name, is the name of the scientist. So in this case, what happens? In the presence of peroxide, or you can have helper, ठीक है, हेल्पर में से कुछ और भी हो सकता है, ठीक है। In the presence of peroxide, what will happen? Yeah, tell me. Any question, Rishita?
Nothing, sir.
Nothing. Okay. In the presence of peroxide, when alkene is treated with HBr, we are only taking the case of HBr because this effect is most prominent in HBr. बाकी HCl, HI में भी होता, but that effect is not very prominent. So we only take the case of HBr. When alkene is treated with HBr, then Br attaches to that carbon which has more number of hydrogens. That carbon which has more number of hydrogens. Okay. Now we are going to see the same case. We are having plus HBr in the presence of peroxide. So peroxide में we are going to take phenol peroxide, ठीक है, और not phenol, sorry, benzene peroxide. आपके पास phenyl है, and with each phenyl we have one oxygen, तो इसी तरह peroxide, ठीक है, तो इसको बोलते हैं benzene peroxide. एक benzene के लिए एक oxygen atom. So we'll have this as the major product, plus we'll have this as the minor product. This will be major, this will be minor. Now, the first step here, it is again, it will be the chain initiation because it is a free radical mechanism. So we'll have PHOO PH. Here we are having two electrons. These two electrons will dissociate in the presence of sunlight or the presence of anything, a small amount of light also, or if you get a, wait a bit, if you give it a small bit of heat also, it is going to dissociate and it will give you PHO free radical. The second step, there will be HBr. So you will have PHO free radical plus you will have HBr. These are free radicals here. So what will happen? It is going to take the hydrogen from here and it will give you POH plus Br free radical. So now we are having Br free radical. The third step, you will have alkene, and alkene is going to react with Br free radical. Now when it reacts with Br free radical, two things can happen. It can either react with this, let us suppose the red carbon atom, or it can react with this green carbon atom. So if it reacts with the green carbon atom first, then what will happen? 1, 2. Then Br will be attached here, and you will get the free radical here. If it reacts with the red carbon atom, then what will happen? The Br will be here, and the free radical will be on the terminal carbon. So here we have a 2-degree free radical. Here we are having a 1-degree free radical. So obviously this is more stable. And the reaction will proceed with the 2-degree free radical. In the first step, what will happen? The first step, you will have Br free radical here, plus you will have one more HBr. Hydrogen from this HBr is going to react with the carbon free radical, and you will get Br. Okay. Plus you will get a Br free radical. Br free radical will then be used in the third step. The third step that we have. Please write this down. Important thing that you have to understand is the how to write the product. ठीक है, जिसको हम लोग अभी देखेंगे.
Done, sir.
Done. Okay. Write on the product for this. Send your answers once you're done.
So from 2 to 5, it's only major products, right?
Yeah, major. For all of them, you have to give the major pros. Okay. What happened, Rishita? Are you facing any problem?
No, sir, one sec. I'm almost done.
Okay. अरे मेजर माइनर नहीं अरे गलत है ना, देखिए. What we learned here, Rishita? See.
Yes, sir, but this is only when peroxide is involved, right?
No, what I wrote here. Or,
Or helper.
ठीक है, we have to do the like Markovnikov में जो आपने किया ना उसका उल्टा करना है, ठीक है, फिर से try कीजिए. The reaction will take place in the double bonded carbon atoms. Okay.
Yes, sir, but if in exams, if they ask to do these reactions, they won't specify what it is. Like they won't specify if it's anti-Marconic rule or just like that, just
Yeah,
using helpers.
obviously. Yeah, yeah, sure, sure. No, no, they will not specify, but I mean, peroxide, H nu, UV, all of these things, they tell you that it is what? Anti-Markovnikov. And if you had something like this, for example, I mean, what you are confusing it is with something like this. For example, if you have something like this plus Br2 in the presence of UV, this is bromination. So we have only Br2, we
Oh,
don't have
okay.
HBr. Makes sense? The reagent is itself different.
Okay, so the first one is right, but the other four are wrong.
Yeah, yeah, correct. In the first one also, you have to tell me which one is the major product.
Uh, the first one is a major product, the other one is a minor product.
Yeah, in the presence of peroxide. Yeah, very good. About the 2, 3, 4, 5, do. Send it once again. You're done.
Yes, sir.
For the second one, major, minor, major. थर्ड वन मेजर में थोड़ा सा आपको लगता है, देखिए फोर्थ वाला भी सही नहीं है. You have to circle the carbon atoms which are having double bond, and then only you will be able to do it correctly. फोर्थ में देखिए आपने क्या मिस्टेक किया है ऋषिता.
I did it. Okay, I didn't do the second double bond.
नो नॉट सेकंड डबल बॉन्ड क्या होता है, एक ही डबल बॉन्ड है. आपने जिस कार्बन एटम पे पीआर अटैच किया उसमें तो डबल बॉन्ड है ही नहीं.
Yeah, I didn't do the
मेजर
second
वाले में
carbon
देखिए,
of the double bond.
है ना. तो यहाँ ठीक है, देखिए सर